what we're going to do here is try to work through the first example of a bearing problem that we saw on Thursday. You can see it says at the bottom, we measure the bearing from point P to point Q to be south 51 degrees west. According to the directions, it says we measure and label the bearing from the first point P to another point Q. So I'm going to go over to my little whiteboard and just start there and hope I can fit this whole thing on the whiteboard without drawing things too big or too small. So there's point P. I know I'm supposed to draw south. Ta-da! I know I'm supposed to go south 51 degrees west. Now south goes this way, so west I'm thinking is about like here. And I'm still on the board, which I'm very happy about. There's Q. Here's our 51 degrees. Now I'm going to go back to the directions. The second step is we look in the problem for where we need to draw the perpendicular. The third point R is usually on this perpendicular somewhere. So I'm going to go to the problem, and it says we would like to figure out, let's see if I can highlight this a little bit so you can see it. We would like to figure out the distance from P to Q, but we can't actually get from P to Q. So, starting from P, we walk 100 feet along a path that is perpendicular to PQ. So I'm going to go back to the whiteboard, and we're supposed to be walking along a perpendicular to PQ. Well, here's PQ, and I just want perpendicular to it. This does not have to be a perfect perpendicular. It just needs to be roughly correct. I'm just making these very long because I don't know where R is. All I know is that R is on there somewhere. Let's go back to the statement of the problem. The next statement of the problem says, from R, remember that's along the perpendicular, we measure the new bearing to point Q and find that it's 28 south, 28 degrees east. Alright, so I'm going to go back over to my picture. And I know that from R to Q, I'm supposed to be looking south and east. Now just for what it's worth, if I guess that R is here, I see that I would actually have to look south and west to Q. So R is on the completely wrong side of Q. It needs to be, I'm thinking, way up here, like that. You can see now that if I look from R to Q, I'm looking down, like that, and I'm looking east, like that. Let's see, I can straighten that out a little bit, I think, without having to kill myself too much. I'm going to go back to the statement of the problem and just see what that says. I was supposed to make south 28 degrees east. Alright, going back. That means this one right here is 28 degrees east, because from R I went south and then east. Now, I've done drawing as much of the angles as I possibly can. I can see my right triangle. They did tell me that when I walked from P to R, I think they went 100. I'm just going to check again. Starting from P, we walk 100 feet along a path that is perpendicular to PQ to get to R. Alright, I'm going back. Here we go. So from P to R, this right here is my 100 feet. Now, to do the rest of the problem, the way I do it, instead of using trigonometry theorems, which we absolutely could, I draw the smallest rectangle that I can draw that includes point R, point Q, and point P. Well, the way I do this is I say which of those is the highest. Well, in this case it's R, and I draw a horizontal at that height. I say which of those is lowest. That's at point Q, so I draw a horizontal at Q. I say which of those is rightmost. In that case that's P, and I draw that. I say which of those is leftmost. In this case that's R, and I can see that that one's already drawn. Now, My right triangle's in the middle right here, and I want an angle, right? I would love to have either this angle or this angle, but I don't have it. So what I start doing is just start labeling as many of the angles as I can until I actually can figure out either this one or this one. For example, that's a right angle because I drew a horizontal then a vertical. This is a right angle because I drew a vertical then a horizontal. This is a right angle because I drew a vertical then a horizontal. It's the same reason up here. I don't want to label it, it's going to get in the way, but that's also a perpendicular. Now here we go. Starting from the 51, I know that 51 plus this angle is 90. Well, that's going to make this 39 degrees, which doesn't give me my angle. I know that this one here plus this one here are 28 degrees. So I'm going to make this one 62. And I still don't have it. I see, however, that this angle, which is inside the triangle, I now can actually figure out, because 62 plus this angle plus 39 all add up to 180. And I'll put that calculation right down here. I'll put 62 degrees plus the angle I want, theta, plus 39 degrees equals 180 degrees. If I start solving for theta, I'm going to see the theta is going to wind up being, I think, 79 degrees. Yay! So I'm going to come into here. I'm going to put my little 79 degrees. I've at least labeled everything. I do want to go back to the problem just to figure out what they're asking for. So I'm going to go back to the problem. Back to the problem. What do they want? They want the distance from P to Q. All right. So I am going to go to my little board, and I'm going to label the distance from P to Q. I'm just going to call this right here L. And then I'm going to put my calculations up here. I have 79 degrees, I have L, I have 100. And I want to think of a trig function that involves this angle, this side, and this side. Well, what I have is that the tangent of 79 is the opposite over the adjacent. So I'm going to use tangent. I'm just going to write down up here that the tangent of 79 degrees is equal to 100 over L, like that. I'm going to solve for L. Let's put a little so. Can I still see the so? I can. So L is equal to 100 over the tangent of 79 degrees. And what I'm going to do is I'm just going to run over to Desmos while I'm sitting here, and I'm just going to type that in. Not putting this in a video, but this is something you can see. Just checking here. All I want is 100 over the tangent of 79 degrees. And I think what I get is, according to Desmos, 19.438. I'll put as many decimal places as I can see here. 438.0309. I think that's as much as I can actually put on the board. And I think this is feet. And that's the whole problem.